Hi guys, I am going to work through that pre 9.4 worksheet, which is just a review of some factoring. So here we go. In the first group of problems, we are going to look for a greatest common factor, otherwise known as a GCF, and that's all we can really do in these first four problems. So let's take a look. So when I look for a GCF, I always look at what's the biggest number that both the coefficients are divisible by. So with 12 and 6, I know that both of those are divisible by 6. So if I divide each of those by 6, I'm just taking a 6 out. And then I look at the lowest power is always what you can take out as far as the variable goes. So this k squared can come out of both terms. So if we divide 12 by 6, that means we have to have 2 left. If we took 2 k's out of k to the power of 4, that's going to turn into k to the power of 2. And then notice that this term is the same as this term, but we do have to have a minus 1 as a placeholder. Now, if you're not sure if you did the problem correct or not, what you can do to check your answer is go back and distribute that term in. So notice that if we check 6k squared times 2k squared is 12k to the power of 4. 6k squared times negative 1 is minus 6k squared. And then just notice there that this matches up with what we started with. So I know that we did the problem correct. All right, so let's try number 2 here. First, we look at the coefficients. So 30, 9, and 6 can all be divided by 3. And then my lowest power is actually, since 6 doesn't have a variable in it, we can't take any variables out. So all we can take out is 3. And then I have 10n squared minus 3n plus 2. And then again, if you want to check that, you could distribute that 3 into the parentheses and see if you end up with what you started with. Okay, let's try number 3. So first check your numbers, 20, 15, and 40. I think all we can divide those by is 5. And then I do have an x in all of the terms. The lowest power is just an x to the power of 1 here. So that's going to be the variable I can take out is just a single x. So then I'm left with 4. If I took the x out of 20x, I'm just left with the number, the constant. And then 15 divided by 5 is 3. I took 1x out, so I have x to the power of 2. 40 divided by 5 is 8. And then x to the power of 4, since I took an x out. Now, you probably should not leave your answer like this. It's a good habit to write these in standard form. So we're going to put the highest power first, so that 8x to the power of 4. And then the 3x squared, that should be squared. And then the plus 4. All right, so this right here would be the best way to write your answer. All right, and then the last one in this group, let's check our numbers here. We have 45, 50, and 20 are all divisible by 5. And now in this example, we actually have 2 variables, so we need to check each one separately. I notice that each term has at least an m in it, so I know I can take out an m. And then notice that not every term has an n in it, so we're not going to take any n's out. All right, 45 divided by 5 is 9, and then I took an m out, so I have m to the power of 1 and n cubed. 50 divided by 5 is 10. I took the m out, so I just have 10n. And then lastly, 20 divided by 5 is 4. Since I took the m out of there, that's all I've got left. And that is factored. Okay, so let's move on to the next part, which is factoring by grouping. And you're going to use this method if you ever have 4 terms. So just keep that in mind. If I don't tell you how to do it, if it's got 4 terms, try to group. All right, so first we're going to take the first 2 terms and group those with parentheses, and the last 2 terms and group those with parentheses. And then we check each group for its GCF. So in the first group in this problem, 15 and 10 can both be divided by 5. And notice that they have a v squared in common. So if I take out a 5v squared, I'm left with 3v minus 2. All right, and you can always just redistribute that to check if it works. And then in the second group, 21v and 14 are both divisible by 7. I can't take any variables out because the 14 doesn't have a variable. So then I'm left with 3v minus 2. Now, when you do grouping, if you did it correctly, and you can do grouping, you should notice that what is left in the parentheses after you take out the GCF should always be identical. So now what we're going to do is we're going to pull these 2 pieces in front into their own group. So this becomes 5v squared plus 7, and then you repeat the 3v minus 2. All right, now the reason that works is we're still distributing that 5v squared to both terms like we were here, and we're still distributing this 7 to both of these terms like we were here. So we haven't really changed anything, we've just made it more compact, and we've completely factored it. Okay, again, just like before, if you're not sure if you did it right, with any of these, you can check your answer by foiling that back out. So for this first one here, let me just show you that this really does work. So 5v squared times 3v is 15v cubed. 5v squared times negative 2 is minus 10v squared. 7 times 3v is 21v. And 7 times negative 2 is minus 14. So now notice this answer here is the same as what we started with. All right, so we know we did it correct. Okay, so let's try another problem here. Number 6, group the first 2 terms and the last 2. And then let's check for a GCF. 3n cubed and 12n squared. Well, 3 and 12 can both be divided by 3. There is at least 2 n's in common, so we have n to the power of 2. And then we're left with a single n in the first term, and then a minus 4 for the second term. All right, so let's check the second group. 8n and 32 can both be divided by 8. And then we're left with an n, and then 32 minus 8 leaves us with minus 4. And that worked out nicely because notice these 2 terms are identical. So I know I did the right thing. This 3n squared plus 8 is going to pull to the front and be my first group. And then this n minus 4 we put to the back as our second factor. All right, and then this is our answer here. All right, and for number 5, this here was our answer. Okay, number 7, let's try this one. Group the first 2 terms and the last 2 terms. And then 28 and 16 are both divisible by 4. And there's an x squared that can be taken out of both. So if I take 28 divided by 4, that's 7. And then I have a single x left. 16 divided by 4 is 4, but I took out both the x's, so I just have 7x plus 4. 21x and 12 are both divisible by 3. And then there's no variables in 12, so I can't take out an x. But then I'm left with 7x plus 4, which is good because these two terms should match, and they do. So now we can take our 4x squared plus 3, pull that into a group at the front. All right, that's our front group. And then we can take and repeat our 7x plus 4 at the back. So that is the factored form of that polynomial. Okay, let's try this last one, number 8. Now, if you have a minus sign, actually, let me do that in a different color. If you have a minus sign in the middle, like we do here, when you group that second part, so these last two terms, if this is a minus sign, that means you have to always change this sign to its opposite. So that's going to become 18r minus 3. So that's very important to remember if there's a minus sign in the middle of your groups. Okay? And the reason for that is if you would distribute this back in, that negative times that negative would turn it back into a positive. So that's why you always have to do the opposite. If this was 18r minus 3, we'd have to go back and change it to a plus. So you always just flip the sign when you group the second two terms. Okay, so let's check our groups. 12 and 2 are both divisible by 2. Oh, and they do have an r squared in common. Then we're left with 6r. Notice that this and this are the same, so if we took out a 2r squared, we have to put a 1, a minus 1 as a placeholder. And then we have minus 18 and 3 can both be divided by 3. And then we're left with 6r minus 1. And that is fantastic because this group matches this group. So now we take our 2r squared minus 3, pull that to the front in our first group, and then we take our 6r minus 1, and that becomes our second group, our second factor, and then this is the factored form of that polynomial. All right, so factoring by grouping can take a little time, but the steps are always pretty much the same. All right, so now we're going to move on to some trinomials, which always have 3 terms. We're going to do a couple of easy ones here. And when we say an easy trinomial, that's when the number in front of the squared term is 1. So in this case, you won't really see an a because it's a 1x squared. So we're just going to make a diamond for these two problems. So we put c in the top, which is 40, and then b in the bottom, which is 14. And we're trying to find two numbers that multiply to give us 40. So they're going to multiply to give us this, and then they're going to add up to 14. If you need to use your factor chart, hopefully you have that handy. If you Google factor chart, you can also find a bunch of options there. But this one's not too bad. I know that 4 times 10 is 40, and 4 plus 10 is 14. So this factors into k plus 4 times k plus 10. And then that's it. We're done. Okay, let's try another one. So this one's got a negative in it, but we put c in the top and b in the bottom. Now make sure you recognize that this negative goes with that 11, so that's very important. So now we're trying to think of two numbers that multiply to give us positive 24 and add up to negative 11, which is a little bit tricky, but negative 3 times negative 8 is positive 14 or 24, and those do add up to negative 11. So we've got m minus 3 times m minus 8, which is our factored answer. All right, and like with any of our problems, you can always check these by foiling this back out. So let's just see if we did it right. M times m is m squared. M times negative 8 is negative 8m. Then we have negative 3 times m is negative 3m. Negative 3 times negative 8 is positive 24. And then we've got like terms here. So we got m squared minus 11m plus 24, which if you check that out, that answer that we checked is the same as what we started with. All right, so kind of the cool thing with factoring, you can always know if you did it right by foiling your answer or distributing your answer back. And if you got what you started with, hey, you did it right. Pretty cool. Okay, so now let's see if the trinomial has a number in front of the squared term. So this makes things maybe a little bit more challenging. So we're going to use, this is called the slide and divide method, which is the way that we learned in class. You may have learned other ways to do this as well. Like guess and check is a big one. You can do grouping. There's other options, but this is the way that we usually use in class. So I'm going to do that. So first of all, you use this method when a is greater than 1. So like notice here we have a 3, here we have a 2. So there's going to be a number in front of the squared term. All right. So step 1 is to multiply our a and c. So then we're going to turn this into a squared plus 7a. 3 times 2 is plus 6. Okay, now with that, we make a diamond. So we have to find two numbers that multiply to 6 and add up to 7, which are 1 and 6, giving us a plus 1 times a plus 6. Now, we've got to get that 3 back in there. So how we can do that is take these coefficients, or the constants, this is step 4, divide the constants by a. So we have to divide the 1 by 3 and divide this 6 by 3. 1 is not divisible by 3, so we bring that 3 and skirt it to the front there. So this becomes 3a plus 1 as our first factor. Notice in the second term, though, 6 is divisible by 3, so this turns into a plus 2. Okay, so this would be our final answer. If you're like, oh man, I don't know if that's right, hey, guess what? You can check it. 3a times a is 3a squared. 3a times 2 is 6a. 1 times a is 1a. 1 times 2 is 2. Combine these like terms. We get 3a squared plus 7a plus 2, which if you notice, that is what we started with. So we did do it correct. All right, one more of those. Or actually there's a few more, but next one. Take our a times our c. Drop the 2, so we have m squared plus 9m. 2 times 10 is 20. Now we make our diamond, put 20 in the top and 9 in the bottom. So if we want to multiply to 20 and add up to 9, we can use 4 and 5, giving us m plus 4 times m plus 5. We got to bring that 2 back in. So to do that, divide your 4 by 2, divide your 5 by 2. 4 can be divided by 2, so this gives us m plus 2. 5 cannot be divided by 2, so we bring that to the front, giving us 2m plus 5. All right, so I encourage you to pause the video and check that that works, but we're just going to keep plugging along here. Number 13, step 1, multiply your A and your C. Drop the A, so we got x squared plus 13x minus 30. Make a diamond. Negative 30 goes in the top, 13 goes in the bottom. We want to find two numbers that multiply to negative 30 and add up to 13. This one's a little bit tricky, but it turns out that negative 2 times 15 is negative 30, and negative 2 plus 15 is 13. So we've got x minus 2 times x plus 15. We got to get that 3 back in there, so to do that, we take 2 divided by 3, and we take 15 divided by 3. 2 can't be divided by 3, so bring that to the front. This gives us 3x minus 2. Whoops, minus 2. And here, oh, that's not right. 15 divided by 3 is 5, so this is x plus 5. And that is factored. All right, last one in this set of problems. So here we go. 2 times negative 10 is negative 20. So I've got x squared minus, you can throw a 1 in front of that x, that might be helpful. And then we have minus 20. So if we make a diamond, we need two numbers that multiply to negative 20 and add up to negative 1. Positive 4 and negative 5 will get us there. So we've got x plus 4 and x minus 5. And of course, we got to get that 2 back in. So divide the 4 by 2 and the 5 by 2. 4 divided by 2 is 2, so this is x plus 2. 5 cannot be divided by 2, so we bring that to the front, giving us 2x minus 5. All right, so kind of the big thing with these problems is don't forget to divide by the A value. That's a big step that students always miss, and then they don't get the right answer. But you'll know you forgot that step if you checked your answer and FOILed it out and it didn't work. A lot of times, this step right here is the one that students forget. All right, and our last couple problems are going to review difference of squares. So you use this method when you are asked to factor an expression with two terms where the first term is something squared, the second term is something squared, and there is a minus sign in between those. Hence the name difference of squares. All right, and they can always be factored, so like when I think of this, I think of square rooting those two terms, and that gives you what A here equals, and then what B here equals. All right, so if we square root 4k squared, that gives us 2k. So we know our A's are 2k. You're always going to have a plus in one of the factors and a minus in the other. And then if we square root 25, that gives us 5. So 2k plus 5 and 2k minus 5 is our answer. And guess what? You can always check it. So if we FOIL this guy out, 2k times 2k is 4k squared. 2k times negative 5 is negative 10k. 5 times 2k is positive 10k. And 5 times negative 5 is minus 25. So here's why it's going to be two terms. This minus 10k and this plus 10k cancel. So we're left with 4k squared minus 25. Hey, that looks a lot like what we started with, so we know we did it right. All right, and last but not least. So the square root of 9x squared is 3x. So that gives us our a's. The square root of 4 is 2. So we know we're going to have a plus 2 and a minus 2. 3x plus 2 times 3x minus 2 is our answer. All right, so I know that was a lot of factoring, just some different concepts we learned earlier. We're going to use those a lot in Chapter 9, so just wanted to do some reviewing of those factoring problems. All right, let me know if you got questions, and have a great rest of your day.